Hello, hey, hi everyone. Thanks for clicking on the video. So guys, the new project that we're going to focus on or we're going to build end to end is called as multi-agent clinical trial intelligence engine. Okay. And from the architecture diagram, you can look at the intensity of this project that we're going to build. Okay. It's a fantastic end-to-end project and we're going to deploy it at a production level. Okay. Which means this project will be live on Google Cloud platform for the end users to use and collaborate or use with, make changes, etc. etc. Okay, cool. Okay, so guys, for this project, we're going to be dependent on Google Cloud platform. Apart from that, we'll be using LangGraph as the agentic framework. Along with that, for memory layer, we're going to be dependent on LangMem. Okay, see, as of now, I'm just giving you a basic idea. Then we'll deep dive into the architecture. You can see these are all the agents that we're going to work with. This is human in the loop gate, backend part, and the observability part. Okay, now how cool is this? This is quite an in-depth end-to-end project that is typically built at an enterprise level. Cool. But before deep diving into this project, okay, let us try to get a hands-on on a few important things. Okay, first and foremost, what does this project even do in the first place? Okay. From the name itself, you can understand that this is with respect to clinical trial intelligence. Okay. See, first and foremost, you can also, by the way, use this project or show this project from pharma domain, from pharmaceutical domain. It can work anywhere. Wherever there's clinical trial, whether it is pharma, biotechnology, anywhere. Yeah. Cool. Now, thing is, what our project does actually. Okay, our agentic framework reads through thousands of real-world government documents automatically. Okay, every clinical trial conducted in the US must registered on clinicaltrials.gov. Okay, this is the website. You can just go and check clinicaltrials.gov. If you want, let me just access. Just give me a minute. Yeah, let me just access that website. Yeah, clinicaltrials.gov. Okay, so if I just go here, okay, this is the website where the entire US research this is National Library of Medicine. This is where you can find all the research. Okay, this is a free public database. Our agent is going to download these records automatically. We don't need to be dependent on any human. Okay, we're going to roughly ingest around 144 research studies, but the project is scalable to 500 plus. That is huge. Let me tell you, that is huge. So basically we're going to be dependent on 144 documents to fetch the knowledge from. Okay, now we're going to take those documents and those documents are now going to be converted into a searchable memory, which means our raw documents are going to get chunked. We know, right, how the standard chunking works. Okay, converted into mathematical representations, that is embeddings, and stored in the database. This means that the system can find relevant studies by meaning and not just keyword. Now that is fantastic. Just imagine, see, this is impossible for a human biological analyst or a clinical researcher, such that they actually, if they see any issue with the research, it is impossible for them to dig out any research paper with respect to that subject in the entire world. But our agent is going to do that. Okay, it is not just going to be dependent on keyword, it is going to be dependent by meaning. Okay, so find the trials where sponsor were quite. Okay, and this is what actually worked. Now what is this? We'll come to that in some videos. Yeah, firstly, it remembers everything. Why, guys? Because we have given a LangMem integration layer. Okay, see, the thing is, we have deployed we are going to deploy the project along with the memory layer integration also. We're going to be dependent on episodic memory, procedural memory, and semantic memory. When we actually go into LangMem, we'll deep dive into it. What is the differences, etc., etc. Okay, so a human analyst forgets what they read 6 months ago, but our project will never forget when in production. Okay, every reasoning session is saved as an episode, and every fact about the sponsor is accumulated over time, and the system gets smarter with every run and not just reset. We're going to have a multi-agent system. If you look closely, we're going to have 6 specialist agents that are going to run in parallel, not even in series. So again, this is enterprise level. Okay, each one of them is going to look out for a different type of problem. One is going to look for broken promises. What are broken promises? Broken promises means, let's say, see, every research that happens in the world, Okay, in this case, it is with respect to pharma research. They see, they end up doing some, like, I mean, they promise something, right? They promise some final results, they promise something, right? So our agent is going to check if those final results, what was promised, was actually delivered or not. Okay, or whether the goalposts were moved quite mid-study, which means at the start I'll say something else, but during mid-study and towards the end of the research I'll do something else. And this is called as outcome switching and is documented as a research integrity problem. Okay, then our next agent, one looks for missing results. We're going to look for missing results. About 30% of the completed clinical trials never publish their results. That is astounding. Okay, by law they must within 12 months. Just imagine, out of 100 research, 30 research never publish their 30 number of researchers never publish their research. And Mosaic finds every single one of them in the corpus, who the sponsor is, sponsor as in who has performed the research, who has backed that research, all of that, how many years are overdue, and whether this sponsor, you know, has done it before. It's like, has this particular bank customer defaulted on the loan, you know, in the past. It learns from the human feedback because we have given human the loop, right? So when a human analyst reviews a signal as to, for example, this was wrong, here is why. Okay, that reason gets written back to agent's reasoning procedure, and the agent reasons differently in all the future sessions, which means even a human in the loop is taken into consideration, right? And at some point of time, let's say if the confidence level goes down, if you see, we have a human in the loop gate, right? If you see low confidence signals, wait for the human decision, approve, then signals table, reject, memory update, and edit and fix summary. Okay, now what is this? We'll come to there when we discuss the architecture diagram. Cool. It writes the intelligent brief for you. So there is one more agent which is going to write that intelligence brief for you. Okay, if you see, there are 6 agents, right? Broken promises, missing results, track record, pattern finder, side effect checker, and timeline analyst. Cool. I to find it very cool. Yeah. All right. And it gives a small team the coverage of a team 10 times its size. Just imagine, this is fantastic. See, if I'm talking about a human analyst, they have a limit. A human analyst will have a limit, right? They can deeply follow 10 to 15 studies, 10 to 15 research papers. But our agent is going to be dependent on, let's say at this point, roughly 150 or so, but it can be easily scaled to 500 research paper documents, or 500, not just research papers, 500 researchers, which is huge. Okay, and with the same depth every single run. The moment new data is available, it processes automatically and no analyst needs to be awake, which is, guys, this is fantastic, let me tell you. Okay, secondly, you might ask, hey Chirantan, but this is great, you know, we are really impressed with the architecture diagram, but what makes it different? So guys, here we are introducing LangMem, right, which is the memory integration part. LangMem is the real production context. Okay, the LangMem framework exists and almost nobody has made a serious tutorial about it. At least in my, if you have seen any serious tutorial, please let me know. But for example, if I want to look at episodic versus procedural memory in an AI agent, okay, if I want to understand what is episodic memory, what is procedural memory, how does episodic and procedural work, okay, I want to see that. And this is genuinely a new idea in the practitioner community. Okay, so now let's say a domain that is viscerally understandable. So 30% of clinical trials never publish their results. Okay, and just imagine, this is also a fantastic domain to work with, right? I was actually taking some time to work on this project. The reason being, I was looking out for interesting domain, interesting project to work on, something that is cool to work with. At the same time, I give you production level value. Okay. So yes, you don't need to be of the medical background to understand why that matters. This problem is real. And the data set is free. That is the best part, right? And the feedback loop closing back into the agent behavior, okay? Which means a human approves or rejects a signal, right? Now the rejection reason updates how the agent reasons the next time, which is very cool, okay? And that is the moment where the system genuinely learns, and it is something no other multi-agent tutorials can show. So this is roughly the like in my understanding, what is it that makes it different? Okay, so roughly this is the diagram that we are going to follow. Okay, So yeah, in the next video, let's try to catch up on the other part, or on the proceeding part of this agent. So I hope you guys are interested and all excited to implement this. Yeah, so am I. So let's get started.